Hello guys and welcome to the first video that talks about the SAT subject test in physics. We are going to solve some real classified questions on every topic. This is Khaled Mustafa and I'm going to be with you in this video. Before we start, let's have a quick overview on the topics covered in the exam. Don't forget that we have 75 multiple choice questions. We have mechanics in the exam that weighs from 36 to 42% for the exam paper. And we have electricity and magnetism that weighs from 18 to 24%. We have modern physics that weighs from 6 to 11%, and we have some miscellaneous questions from 4 to 9%. Waves and optics from 15 to 19%, heat and thermodynamics from 6 to 11%. Okay, very good. Today we're going to start with lesson 1, which is kinematics in 1 and 2 dimension. Now we are going to solve some real classified questions on this topic. Bring a paper and pen with you and let's start. We have now for question number 1, a ball thrown vertically upward is released at time t equal 0. If the air resistance is negligible, which of the following graphs best represents the velocity v of the ball as a function of time? Now, when we have a ball that is vertically thrown upward, it moved like this. Let's call this point number 1, and let's call this point number 2, and this point number 3. We have a gravitational acceleration which is 10 meters per second squared, acting always downwards. So from point number 1 to point number 2, the ball is moving against gravity, which means the velocity is decreasing. At point number 2, which is a maximum height, we have a 0 velocity. Now the object started to come back down with gravity from point 2 to point 3, which means we have an increasing velocity. So the correct answer is going to be C. This is point number 1 and this is point number 2. From point number 1 to point number 2, we have a decreasing velocity until we reach the maximum height at point number 2, where velocity equals to 0. And from point 2 to point number 3, now the ball is gaining velocity because it's moving with gravity, but in the negative direction, in an opposite direction. Okay, now let's move to question number 2. The 5 labeled curves below show speed as a function of time for 5 cars. Which car is moving the slowest at time t1? At time t1, how to find the slowest car at time t1? Just draw a vertical line at time t1 and figure out what curve or what line first intersects that vertical line. It's very clear that car D has the slowest speed. So the answer is D. Question number 3. Which car travels the greatest distance? The greatest distance in the speed-time graph. To have a greatest distance in a speed-time graph, don't forget that the area under the curve or the area under the graph is the distance. So area of a speed-time graph is distance. What about the slope of the line? If we have a graph drawn between speed and time, don't forget that slope of this line is the acceleration. Now, to find the greatest distance, we have to find the greatest area under the curve. Can you figure out what car has the greatest area under the curve? Yes, it's B. Car B has the greatest area under the curve. That part has the greatest area under the curve. So it has the greatest distance. So B is the correct answer. Okay, now for question 4. Which car experiences the greatest instantaneous acceleration? Now, to have the greatest acceleration means to have the greatest slope, the greatest steepness. Which car has the greatest inclination or steepness? Yes, it's A. Car A has the greatest slope, which means it has the greatest acceleration. So A is the correct answer. Let's move to question number 5. For questions 5 and 6, an automobile starts from rest and moves along a straight road. In the graph below, the distance x of the automobile from its starting point is given as a function of time. Question number 5. Which interval is the automobile stationary and furthest from its starting point? Stationary means at rest, means velocity equals 0. So, which interval has a stationary core? Yes, it's D, because from this point to this point we have a horizontal line, which means that the car is stationary or at rest. As time passes, we are still at the same distance. We are not moving. The car is not moving. The automobile is not moving. So we have interval D is stationary. Question 6. During which interval does the speed of the automobile have its maximum value? Now we have a graph between distance and time. The slope of the distance time graph is the speed. So to have the maximum value for speed means to have the maximum value for slope. Which interval has the highest inclination or steepness, the highest slope? Can you figure it out? Yes, it's E. E has the greatest steepness, the greatest slope. It doesn't matter whether it's positive or negative, we have the greatest inclination. So interval E has the highest slope, which means the maximum value for speed. Question number 7. Which graph shows the speed as a function of time for an object falling with a constant non-zero acceleration? Falling object. Falling objects fall under gravitational acceleration, which is 10 meter per second squared, and it's constant. So when we have a constant acceleration, means we have an increasing speed. So we can eliminate A, B, and D. C or E, which graph has a constant acceleration? Constant acceleration means constant slope for the speed time graph. Constant slope goes definitely for the straight line. So choice C is the correct answer. What about choice E? Choice E has a variable slope. The slope at every point is different. So the acceleration for choice E is not constant. Let's move now to question number 8. A ball is launched straight up from the ground level with an initial speed of 30 meters per second. Assume that the magnitude of the acceleration due to gravity is 10 meters per second squared, and the effect of air resistance is negligible. The height x of the ball above the ground is plotted versus time t. We have questions 8 and 9. For question 8, what are the speed and the acceleration of the ball at t equals 3 seconds? At t equals 3 seconds, it's very clear that this is a maximum height. And as we have said before, that at maximum height, velocity always equals to 0. What about the acceleration due to gravity? It's constant. It's constant at every point. So we have question 8, a zero velocity and acceleration 10 meters per second squared with a negative sign because the ball is being launched straight up against gravity. So we have a gravitational acceleration of negative 10 meters per second squared. So now we have B is the correct answer. For question 9, what are the speed and the acceleration of the ball at t equals 6 just before hitting the ground? At this point, again, at every point on the path of the trajectory, we have a constant gravitational acceleration, which is 10 meters per second squared. So at this point, we have 10 meters per second squared acceleration. What about the velocity at this point before it's hitting the ground? Well, for every projectile, velocity at this point, the initial velocity at this point is exactly the same at this point just before hitting the ground. And at this point is the same at this point, and so on. And at the maximum height, we have a zero velocity. So the velocity starts to decrease on its way up until it reaches the maximum height and velocity equals to zero, and then it started to gain velocity when it's moving down with gravity. So at this point, we have an initial velocity, we have an initial speed of 30 meters per second, which means at this point, just before hitting the ground, we have the same speed, which is 30 meters per second. So D is the correct answer. We have 30 meters per second for speed and negative 10 meters per second squared for the acceleration. Now let's move to question number 10. Which of the following graphs of displacement x versus time t shows an acceleration that is negative and approximately constant? Negative acceleration. Now, negative acceleration means we have a decreasing velocity. The object is slowing down due to the negative acceleration. And here we have a graph drawn between displacement and time. Remember that slope equals velocity. Yes, slope equals velocity in displacement time graph. In displacement time graph, the slope equals the velocity. So we have a decreasing velocity, means we have a decreasing slope. Decreasing slope, so we can eliminate A, C, and D. Which graph is correct, B or E? The slope for graph B is constant. Slope for graph B is constant, which means we have a constant velocity. Slope for E is not constant. Slope is changing at every point. Slope is changing. So when we have a negative acceleration, we have a decreasing speed which is variable, not constant. We have variable speed. So variable speed means the slope is not the same at every point. So E is the correct answer. Excellent. Let's move to question 11. A cart moves in a straight line. The cart's displacement in meters from its starting point is plotted above as a function of time in seconds. So we have a graph between displacement and time. We have a graph for a cart moves in a straight line. Don't be deceived. This is not a projectile that is thrown up in the air. We have a graph drawn between displacement and time for a cart moving in a straight line. What does this graph mean? It means that the cart started at time t equal 0 in a straight line, and it moves until it reached 20 meters displacement at 2.5 seconds, and then it returned back. It returned back to the same starting point at the 5th second. Okay? For question 11, the instantaneous speed of the core at t equals 2.5 seconds is at this point. At this point, the core changed its direction. Instantaneously, when an object changes direction, it will have a zero speed instantaneously when it changes direction. So at this point where direction is changed, the car changed direction, it has a zero speed. For question 12, during the interval from 0 to 5 seconds, the average velocity of the car is average velocity. The average velocity equals displacement over time, or total displacement over total time. What's the total displacement in this graph? The object started at this point and then it came back to the same point. No change in the initial and final position. Displacement is the difference between the initial and final positions. So when an object came to the same starting point, it's made a zero displacement over 5 seconds. So 0 over 5, definitely the answer is A. Let's move to question 13. Each of the following graphs represents a physical quantity y plotted as a function of time for an object moving along a straight line. For question 13, y is the velocity of an object. Now consider that y for 5 graphs is the velocity of the object that has a constant negative acceleration and a positive velocity at t equals 0. Now we would like to graph a relationship between velocity and time for an object that has a negative acceleration. Having a negative acceleration means you have a decreasing slope. You have a decreasing velocity. So we have a decreasing velocity and the velocity is positive at t equals 0. A positive velocity and t equals 0 and it started to decrease. So we have B is the correct answer. For question 14, y is the displacement of an object that has a constant positive velocity and a positive displacement at t equals 0. Now we would like to find the relationship between displacement and time. Displacement of an object that has a constant positive velocity. Constant positive velocity means we have a positive slope. Velocity is the slope of displacement time graph. We have a constant positive velocity means we have a constant slope. And a positive displacement at t equals 0. At t equals 0 we have a positive displacement and a constant positive slope or a constant positive velocity. So we have C is the correct answer. For question 15, y is a displacement of an object. So again, we have a graph between displacement and time of an object with a constant positive acceleration. Constant positive acceleration. When we have a positive acceleration, means we have increasing velocity. We have an increasing velocity. Don't forget that velocity is the slope of displacement time graph. Increasing velocity means we have increasing slope, not a constant slope, which is definitely not a straight line relationship, not a linear relationship. So an increasing slope means E, we have a curve and the slope is variable at every point. So E is the correct answer. Perfect. Let's move to question 16 and 17. In the following graph, the speed of a small object as it moves along a horizontal straight line is plotted against time. We have a graph between speed and time. For question 16, the magnitude of the acceleration of the object during the first 3 seconds. Acceleration. How can we get the acceleration from speed, time, graph? Speed, time, graph. Yes, acceleration from the speed, time, graph is definitely the slope. So to get the acceleration during the first 3 seconds, get the slope of this line. Can you get the slope of this line? Slope is rise over run. We have a rise, which is 12, and we have run, which is 3. So the acceleration is 4 meters per second squared. For question 17, the average speed of the object during the first 4 seconds. Average speed. Can you remember the rule of the average speed? Average speed. Yes, average speed is the total distance over the total time. How can we find the total distance during the first 4 seconds? The total distance. How to find the total distance from the speed time graph? As we have said before, that the distance from the speed time graph is the area under the curve, area under the line. So during the first 4 seconds, we need to find the area of this shape. To find the area of this shape, to find the total distance, just you can find the area of a rectangle and the area of triangle. The area of this rectangle is 1 times 12. The area of the triangle is half times base times height, which is half times 3 times 12. So the total area of this part is going to be 30 meters. So the total distance is 30. The total time is 4 seconds. So 30 over 4 is 7.5 meters per second. Fine, let's move to question number 18. We have a graph between speed and time, and we would like to find the acceleration of the automobile at the end of the 60 seconds. Again, how to find the acceleration? From the speed time graph. Acceleration is the slope. So to find the acceleration during the first 60 seconds, we need to find the slope of this line. Slope is rise over run. The rise is definitely 15 and run is the 60 seconds. So 15 over 60 gives 0.25 meters per second squared. Question 19. We have a graph between velocity and time. The figure above shows a graph of speed v versus time t for a car moving along a straight line. We have a car moving along a straight line, straight level road. Which of the following statements about the motion is true? A. The car is not moving at t equal 0. No, at t equal 0, we have a positive velocity. We have a value for velocity, so A is not correct. B. The car returns to its initial position at time t equals 5. No, at time t equal 5, the car stopped. We have a 0 velocity. So the car was moving at t equals 0 to t equals 5, and then at the 5th second it stopped. It doesn't came back to its starting point. B is not correct. C. The displacement of the car from its initial position is increasing at all times from 0 to 5 seconds. Yes, from 0 to 5 seconds the car was moving along a straight level road and then it stopped. So the displacement was increasing at all times from 0 to 5 seconds. This is the correct answer. Let's check D and E. The acceleration of the car reached its maximum value at t equals 2. At t equals 2, we reached the maximum value for velocity, not the acceleration, so it is not correct. E. The velocity of the car is negative between t equals 2 and t equals 5 seconds. At t equals 2 and at t equals 5, we have a decreasing velocity, but it's positive velocity. The object did not change its direction. The velocity was decreasing, but still positive velocity. So E is not correct. Excellent. For questions 20 to 22. The sketch above shows the path of a heavy iron ball thrown by an athlete. The ground is level and the dashed lines are parallel to the ground. Assume that the frictional forces acting on the ball are negligible. Question 20. The speed of the ball at point 1 when it leaves the hand of the athlete is the same as its speed at point. The speed at point 1 for a projectile is the same as the speed at point V. It's symmetry. So V has the same speed of I. For question 21, the potential energy of the ball is greatest at point. Potential energy. Can you remember the potential energy? Potential energy is mass times gravity times height. So the more you gain height, the more you have potential energy. So the potential energy is maximum at the greatest height. So it's definitely the answer is C. Question 22. Which of the following is a true statement about the acceleration of the ball during its flight? The acceleration of the ball during the whole flight. Don't forget, any projectile is being acted upon by a gravitational acceleration. The gravitational acceleration is 10 meters per second squared, acting always downwards. So the acceleration at this point is 10 meters per second squared. The acceleration at this point is acting downwards 10 meters per second squared. So the acceleration during the whole flight is always constant, which is 10 meters per second squared. Oh, let's be more precise. It's negative 10 meters per second squared because the ball is being projected upwards against gravity. So at all points, we have the same gravitational acceleration. We have the same acceleration, which is the gravitational acceleration. Question 23. We have a graph between position and time. Position means displacement or distance. The graph of the position versus time for an object moving along a straight line is given above. During the time shown on the graph, the speed and the acceleration of the object will have which of the following characteristics? How could you find the speed from a position time graph? Position time graph. Yes, speed is the slope. We have a straight line between position and time. So having a straight line means we have a constant slope. Constant slope means constant speed. We have a constant speed, which means constant speed means no acceleration. The car is not accelerating. So we have zero acceleration because we have a constant speed. So now we have a constant but not zero speed, and we have a zero acceleration. By the way, this cannot happen. You cannot have a constant speed with an increasing acceleration. Let's move to question 24. The graphs below represent velocity as a function of time for 5 different particles, each moving along a straight line. Which particle experiences the greatest displacement between t equals 0 to t equals 1? Greatest displacement. How can we find the greatest displacement from velocity time graph? Velocity time graph. Don't forget that the area of the velocity time graph is the displacement. So here, to find the greatest displacement means to find the greatest area. Don't forget that velocity and displacement are vectors, which means they have magnitude and direction. So this is a positive area and this is a negative area. This is a positive and negative. So it's definitely D has a zero area because we have two identical triangles. Which graph has the greatest area? Yes, it's B. B has the greatest area under the curve. So it has the greatest displacement. That's all for today and see you in the next video. Thank you so much.